Hello, Daryl here. The channel is Programming in Any Language. The supporting website is programminginanylanguage.com or black-duck.com. They both take you to the same place. And it's a place where you'll find the videos and PDFs of the code. The video is Inheritance. This is the first video exploring object-oriented programming. There are a number of topics to consider when exploring OOP. The first we look at is inheritance. Inheritance, I believe, is easy to understand. If you build something that something has certain properties, could be height, width, depth, color, and many other things. Now, if you take that thing and build something new with it, that new thing contains all the properties of the first thing, plus any new properties you might have added. Example, you build a doghouse. 4 walls, a pitched roof, and a door in the front wall. You call it doghouse. Now, suppose you make an identical doghouse but add a front porch to the dog to rest on. We'll call that the luxury doghouse. It has all the properties of the first doghouse with the added property of a nice porch. That's inheritance. This video will show you how you can extend classes using inheritance. When first working with object-oriented programming, you encounter terms like inheritance, polymorphism, interfaces, things of that nature. They all may seem kind of abstract or confusing at first, and we're going to take each one of those things and kind of break it down so we kind of understand what they actually are. We're going to start with inheritance. Inheritance allows a new class to extend an existing class. The new class inherits the members of the class it extends. It helps to specialize a class from an existing class. Apple and Cherry are two specialized members of the Pie class, for example. It helps to generalize common members of many classes in a parent class. Siberian Huskies, French Poodles, Labrador Retrievers, they all have common characteristics of a dog. When one object is a specialized version of another object, there is an is-a relationship between them. Apple pie is a pie. Cherry pie is a pie. All pies have certain common characteristics and can be described by the pie class. The apple pie has its own unique characteristics to be described by the apple pie class. The cherry pie has its own unique characteristics to be described by the cherry pie class. Looking at the 3 different types of pies, so they all look kind of similar, but they are different. And is-a relationship implies that the specialized object has all the characteristics of the generalized object. And we see that the apple pie class, the cherry pie class, they all have the crust, they're all round, and they have pie dough, as the pie class has. The specialized object has additional characteristics which make it special, which a generalized object does not have. For example, while the apple pie class has all the characteristics of the pie class, it also has apple filling. The cherry pie class also has all the properties of the pie class, but it also has cherry filling, which makes it unique. In object-oriented programming, inheritance creates an is-a relationship among classes when you declare a class to be a specialized class of another. Specialized is a generalized. In other words, a German Shepherd, specialized, is a dog. That's generalized. A car, specialized, is a vehicle. A square, specialized, is a shape. A hockey player, specialized, is an athlete. This allows you to extend the capabilities of the class by creating another class that has a specialized version of it. Now, what are we doing with all this? Well, inheritance involves base and derived classes. A base class is the generalized class and is sometimes called a superclass. The derived class is a specialized class that sometimes called a subclass. You could think of the derived class as an extended version of the base class. The derived class inherits field, properties, and methods from the base class without any of them having to be rewritten. So whatever is in the base class gets put into the derived class. You don't have to do any more work with that thing. You can add it as your specialized pieces. New fields, properties, and methods may be added to the derived class to make it special. For example, here's the vehicle class. If we look at it, we have the vehicle class here. We've got make, model, mileage, price, and so on. We've got a number of things in the constructor, a number of fields in the constructor. We have the ability to get and set those properties as we wish. Now, if we make a car class, it can be an extension of the vehicle class. And we actually spell it out right here. It has all the characteristics of the vehicle class, make, model, mileage, and price, but also doors. The car class is derived from the vehicle class. It contains all the properties of the vehicle class plus its own unique door property. In C# generic format, to declare inheritance, the class header is car, vehicle, colon, car. Car is a derived class. Vehicle is the base class. The colon indicates that the class is derived from another class and thus gets all the properties. In this case, we have the vehicle class being our base class here, and we have a car class, truck class, and an SUV class are all derived from the vehicle class. And you can see the vehicle class right here, the car class right here with doors. We have the truck class right here. It's derived from vehicle. It has a drive, two-wheel drive, four-wheel drive. And the sports utility is derived from the vehicle class as well. Its unique property is passengers. You might have a dealership whose inventory includes three types of vehicles: trucks, cars, and SUVs. The dealership keeps the following data: make, model, mileage, and price. Each type of vehicle has the above data, the stuff right in here. In addition, each type of vehicle has its own specialized data. Cars include the number of doors, trucks include the drive type, four-wheel drive, two-wheel drive, SUVs includes the passenger capacity. We can show that by creating a short demo of how we can actually put something like this together. Right here, you're looking at an application that will accept user data, entering the vehicle data information, make, model, mileage, and price, which are the characteristics of the vehicle class. We're also going to be adding the car class property, the doors, into this thing. So we're setting it up so even the doors can be entered here. That means we're going to need a vehicle class and a car class derived from the vehicle class to make this thing work. Well, create object will then take that property, allow us to enter the data, and then it'll take those properties then and from the car class and put them out into the labels that you see right here. So to get started this, we're going to go ahead and create the vehicle class first. So we're going to add the vehicle class. It'll be a class. We'll call it vehicles. Vehicle. Add it. The code comes up. We end up with a class vehicle in here. We're going to create the constructor, which will sit right here. And then we'll add the get and sets, the properties, to this class. And they're all set. So this is our vehicle class. We've got our constructor here with make, model, mileage, and price. We're setting the price as a decimal, integer for the price, for the mileage, and two strings of the make and model, as you can see down here. Now, what we're going to do is we're going to extend this vehicle class by creating the car class. So I'm going to go back over to this, and I'm going to add a new class called car. Once you do that, its code comes up. Now, what we want to do is we're going to extend this thing, so we're going to have to say that we want this thing, car, is going to be an extension of vehicle. So we put the word vehicle in there. And now we add its constructor. Remember, it's going to be using all the properties of the vehicle class, plus the doors. And we'll need the get set for that. And we're good to go. So there's our car class all set to go. So we're sitting here with a form design. We've got a vehicle class and a car class in here. So how do we make this thing work? I always like to do my exit routine first, which we have set up as a button exit right over here. By the way, as long as we're looking at this, we can see button exit, we can see create, button create objects. We have labels called label make, model, mileage, price, and doors. And we've got text properties of text make, txt model, txt mileage, txt price, txt doors. That's all we have here. So we'll double click on it, exit, and we'll just basically close this form. That takes care of that. Then we'll look at this thing and see what we actually need to do. Well, we'll go to the create object piece here. One thing we're going to want to do is we're going to want to create a new car object. That consists of setting up my car equals new car, making that image from that particular class. Let's bring in the make and model. We simply have to say my car dot make is equal to text make dot text. My car dot model is equal to text model dot text. Very simple. Now we need a couple of variables up here. We're going to be bringing in mileage, price, which is coming in as a decimal, and doors, which is coming in as an integer. This is the property that is specific to the car class. The other two are going to be coming in from the vehicle class. So we need to know how to get those guys. And it's pretty straightforward to do that, too. We go if. We grab our mileage this way. So if the mileage comes in as a true integer, we can do something with it, else invalid mileage. So successfully we can have our int mileage coming in there in our try parse. And we're going to check the price. If we'll send that out. And this will also have an else to it. There'd be an invalid price there. Otherwise, price is equal to decimal price. And we got one other thing to grab now, and that's the doors. So again, we do another try parse. We'll go out int doors. And of course, if it fails, we have invalid number of doors. Otherwise, we go ahead and simply say my car dot doors is equal to int doors. And that's the extent of it. So basically, it's a little complicated from the standpoint that we've got integers and decimals coming in. We've got to use try parses to actually make sure we're coming in with legitimate data. The string data is very easy to just bring in. So this you need to do your try catch in, but it gets the data in there. And this is essentially it. So what's happening right here is we're creating that new car class called my car, which inherits, of course, the vehicle properties. We're able to use all that in our program. Will this thing work? Let's take a look. It looks like it's going to, but how's it going to put anything out here? Put in Toyota, Tundra, how about the Corolla? Mileage 27,000, price 23,000, doors 2. Go down to create object, and it seems to have done nothing. It didn't crash or anything, but obviously nothing's coming out here because we haven't done this part yet. So let's escape out of this thing and fix that piece up. Once we've actually created this, it's a matter of going ahead and just displaying all the data in our program. And we can do that right down here by simply putting these labels, filling it with the data from the class, my car class. There's the model, make, mileage, price, and so on down the line. That's all we need to do to make that happen. Do a file save. Let's take our form design, have it start up in the middle, and let's run this thing. This time we'll go ahead and put in our Toyota, Corolla, 27,000 miles, price $23,898, doors 2. Go ahead and create the object. Bang, comes in with our 2 properties. It formats our price to $23,898 Doesn't do anything with the mileage, it leaves it alone, but it brings in that data all coming from that class. So that's very simply how you can extend a class by using inheritance to take our vehicle class and create a car class with it that has the properties of the vehicle class in it. We'll look at an application of this where you can see even more of this happening using truck and SUV data, but that basically is how to extend a class in a nutshell. That's the basis for extending a class through inheritance. In the application section, you'll find a nice project that extends a given class 3 different ways and uses all 3 in the same application. Check it out. Meanwhile, thanks for watching. Visit the website when you get a chance, and please subscribe to the channel. There's more stuff coming every week. We'll see you in the next video. Take care.